This is Jared Monhau's recording for the Markov model name generator. We start off by demonstrating the code as it works. I've got it loaded into the Python shell, so I can just call the main start method. Prompts me for a male or female names, and I'll select female in this case. Then it's asking for a minimum length. Must be greater than or equal to 2. We're not going to generate one letter names, so we'll say 5 in this case. And then a maximum length needs to be greater than or equal to the min. So if I press 3, which is invalid, it'll prompt me again until I enter something valid. So we'll say 8. So all of our names should be between 5 and 8 characters. The number of names that I'd like to generate, we'll generate 7 names for this run. And you can see it outputs quickly 7 names that are all female gender names between 5 and 8 characters long. So now to actually look at the code, we called that main start method, so that handles kind of the different pieces of work throughout this process. So first it's prompting the user for the various input fields that we care about. So getting the file name will, as we see down here in this section, ask the user to enter M or F for male or female and then return the corresponding file name. Min length and max length, we talked about some of the constraints there. Min length needs to be in this function greater than 2, and the max length needs to be greater than the min length. Number of names, that's also pretty straightforward, probably not worth looking at. The names list is what actually reads in this get names function. It reads in the names from the text file and just splits them into a list and returns that list. Next we generate the dictionary that will be used as the data for the Markov model. That's the get names dict function. Oops. So if we go to that function, what it's doing first is prepending and appending underscores to each name in the list, and that'll be used for easier processing later on, as we'll see. Then it loops through each name in our input list, and starting with the first 2 letters in the name, that is the key to our dictionary, it will say, see if that key already exists in the dictionary. If it does, don't do anything. If it does not, enter it as a new item in the dictionary with the value as an empty array. Then it looks at, okay, what in the current name is the letter after those 2 letters that we just looked at? So to start, it'd be the 3rd letter in the name. Append that to the array at that the first 2 letters are the key for in the dictionary. So it's going to loop through each name, say, look at 2 letters at a time in the name until we've reached the end of the name, and then append to the dictionary, or to append to the array for those 2 letters, the letter following those 2 in the name. After we've generated that data, we will say, okay, we want to create an array of actually generated names. So until we've actually completed the number of names that the user has requested, we'll continue to get output names. And that get output name method starts with the first 2 letters of underscore underscore. And that's why we prepended each name with underscore underscore. And it says, get me the number of entries in the array of the dictionary field where the key is those previous 2 letters, starting with underscore underscore. So every time there was underscore underscore in a name, the next letter after that was added to the array in the dictionary. We say, get me the number of those, then choose an index at random from those number of entries, and actually get me the value at that index. So if a certain letter appeared more after the underscore underscore, it would appear more times in that array, and thus have a higher probability of coming up as our next letter. And those probabilities then correspond to the actual probabilities that the next letter appears after a name in our input list. So we continue to do that. We shift the previous 2 letters up by 1 every time, and then continue to say, all right, do that same process of finding a random integer or random index in the dictionary, and then appending that to our output name that we'll return. As soon as we find an underscore, we know we are done, because the name will always end in underscore underscore, because we appended that to each name. The last thing is to check the constraints, so make sure that the length of the current name is between the minimum and the maximum, and make sure that the current name is not in the list of actual names and then if not, if it passes all the checks, add it to the array, and then when we've completed the array to the number of names that the user requested, print that out to the console. That's it. Thanks for listening.